Okay, hello guys, welcome to Mobilemaths. This is Gamchurai. So today I want us to go through the Cambridge O-level paper, Syllabus D, variant 402411, May-June paper. So this is a 2-hour paper, paper 1. Let's see how it goes. Okay, so let's start with number 1. Okay, so we are asked to work out 1,234.4 divided by 8. So basically, what you can do, you can say 1,234.4 divided by 8. The simplest way you can do, we have 8, and I think 4 can go into 8 there. So I can work with, first of all, by dividing by 4 or 2. Let's start with 2. So this becomes a 4. This one a 6, a 1, remainder 1 here, a 7, comma, a 2. So 4 was going to be working. So I now have like 617.2 divided by a 4. Okay, so let's take 2 into, I think even 4 can go there. Let's take 4 directly. So we are now dividing 4 straight there. I'm going to get 4 into this one, 1, remainder 2. 4 into 21, that's a 5. Remainder 1 into 17, that's a 3. Remainder 15, 16, 17, 2. So I have that's a 4. 4 into 17, that's a 4 here. This is a 4, guys, sorry. So I have 154 point, so remainder 1 here. So 4 into 12, that's a 3. So our answer is 154.3. Okay, let's move on. Now I have 3 over 7 of 56. So basically what it means is we are saying 3 over 7 times 56. Okay, so we can check 56 divided by 7. 7 can go into 56 8 times. So 8 times 3, that will give me a 24 here. Okay, let's move on. Now I write down the fraction of this 3 by 3 square that is shaded. Okay, so basically we have one shaded part there. Then I've got a half here, this one, and a half here. This is gonna give me a 1 whole number. So I now have 2 whole numbers, 2 whole boxes. Okay, then let's see, I have this one and this one. If I add them together, they are going to give me a 1 box again. So I can add here plus another 1. So in total, the boxes that I have added are like 3 over what? So you see 3 times 3 just by this here, 3 by 3 gives us 9. So I can work using that, or else I can count and say 1, 2, 3, 4, 5, 6, 7, 8. I have 9 boxes. So all in all, I've got 9 boxes. So I can say this 3 over 9, and we simplify it. 3 into 3, 1. 3 into 9, that's a 3. So our answer is going to give us 1 over a 3. Okay, let's move on. Evaluate 0.5 squared. So basically what it means here is we are saying we are having 0.5 times 0.5. Okay, so basically what it means is that I normally work it like 5 times 5, then I know it's 25. So I write my 25. Then I count the number of digits that I have after the comma. I have a 1 and a 2. So I'm going to say a 1 and a 2. So I put a 0 point like this. This is basically normally what I do. But if you want, another method is you can say 0.5 times 0.5 here, like this, okay? Let me remove this one. So this is going to give me 5 times 5, my 25, 5 times 0, that is 0. Then I count again the number of decimals that I have, and I put again my comma there. So that's how we get 0.25. Okay, let's move on. Okay, number 3, we have this. So this part here is basically 90 degrees. So the question, I'm sure, is going to ask us, what is the value of x? Let's see. Okay, fine. The diagram shows 4 straight lines meeting at a point. So what we know at a point, all angles at a point, they add up to 360 degrees. Okay. So they want us to find the value of x. So what we can say is that to get x, we are going to say x degrees is going to be equal to, we said angles at a point, they add up to 360 degrees. So I can say 360 degrees minus 90 degrees minus 40 degrees minus 120 degrees. Okay. So basically, we are going to get x degrees is equals to 360 degrees minus all of that, adding 120 plus 90, that's 210 plus that one, that is going to give me 210 plus 40, that's 250, sorry, that is giving me 250. Okay, so that's 250 degrees here. So 360 degrees minus 250, that will give us 110 degrees. So that's how we get our 110 degrees. Okay, so that's the value of our x, 110 degrees. Okay, let's move on. Fine. Now we have got AB is a straight line, and BCD is an equilateral triangle. So what we know from an equilateral triangle is that all the angles are equal. So if all the angles are equal, it means this is going to be 60 degrees, 60 degrees, 60 degrees, because all the angles in a triangle, they add up to 360 degrees. So if you add 60 plus 60 plus 60, you're going to get, it's 180 degrees. So it's going to be too much. Okay, fine. Then we also know that angles on a straight line, this is a straight line, if you can see this one, please don't mind my line, it's not as straight as I had assumed. So this is a straight line, yes. Angles on a straight line, they also add up to 180 degrees. So to get our y, we are going to say y degrees is going to be equal to 180 degrees minus the 60 degrees, that is this side, this one. Okay, so if we do that, we are going to get ourselves 120 degrees. So that's our angle for y. So our y is 120 degrees. Okay, please, you see these questions, they've got 1 mark, 1 mark, 1 mark. Try as much as possible to get all those 1 mark. Okay, let's move on. We have Benjamin. Okay, so they're saying Benjamin's age is 2 years. Mariam is 5 years younger than Benjamin. Write the expression for Mariam's age in terms of t. So basically, we are saying Benjamin is older than Mariam by 5 years. So the expression is basically t minus 5 for Mariam. Let's move on. They are saying Colin's age is twice Benjamin's age. Okay. Then write an expression for Colin's age in terms of t. So remember, Benjamin's age, we said it's a t. So if Colin's age is twice, so we simply say 2 times t. That's the expression. Okay, let's move on to the next question. Given that a is that, okay, fine, evaluate 5a minus 2b. Okay, fine, let's evaluate. So we have got 5. For a, we are substituting our 3. Okay, let's substitute. So this is going to be 5 times a 3. Let's put brackets so that we won't have challenges on seeing, am I going to multiply first or what? So then we have 2 by our b is a minus 2 there. So we can say minus 2 there. Okay, fine. So let's simplify this. 5 times 3, that is giving us a 15 here. then minus here 2 by minus 4, that gives us minus 4. Okay, so now here we have a minus and a minus. This becomes a plus. So we now have 15 plus a 4. This is going to give us a 19. So our answer is 19. Let's move on. In set 1, set of brackets to make the calculation correct. Okay, fine. So you just need to put some brackets and see if the expression is going to be correct. So for example, if I say 5 plus 3 there, I get 8 times 2, that's 16, minus 7, that gives me 9. So I can say, first of all, I'm going to add these 2. Then I multiply, because we have what we call BODMAS, okay, and BODMAS. These are usually confused BODMAS, but you can see that from this expression, if because this is my addition. So my addition is after either multiplying and division here, but I can do the addition, then this becomes valid. So let's just put the brackets there. Okay, fine. Let's move on to the next. Insert plus or minus. Okay, fine. It's another one. So 5, I can say 5 times here, 3, 5 times, okay, 3 times 5. Then here I can say a minus, and let's say a plus here. Let's see. So here I'm going to get 15 minus 2 plus a 7. What does this give me? It is going to give me 15 plus a 7, then minus a 2. So I'll get 22 minus 2, and this gives me a 20, which is this value we are wanting. So this is how we can put the signs. So this one, there's no formula of working it out, but you can do trial and error and check if it's going to give you 20 as your answer. Okay, complete the pattern so that AB is the only line of symmetry. Okay, so line of symmetry, remember, you are like, if you have a paper, you are folding it like the way I'm doing. So if I can do that, I can say, okay, fine, for this one, I can have this one like this. Then this one can go, let me see. This one can go, this one will be a straight line to that point, yes. Then here I have a straight line like that. So that's how you can complete it, such that if you are to fold it, you get one line of symmetry. Okay, then let's see the next question. The next question is saying a hexagon has rotational symmetry of order 6. Okay, so basically when it's of order 6, what it means is that this is a regular polygon. Okay, it's not an irregular. It means all the sides are going to be equal. That's basically what we are saying. So we can also say all sides are equal. Okay, that's another important, because we are able to make lines of symmetry or rotational symmetries. Then they say the perimeter of the hexagon is 30 centimeters. Okay, so guys, okay, before okay, they are saying draw a sketch of the hexagon, labeling the lengths of the sides. Hexagon means, hex means 6. So I can draw a sketch and make sure that all the sides are going to be equal. Please don't mind me, but you can try better than me. Okay, so this is 1, 2, 3, 4, 5, 6 sides. Okay, so this is our hexagon, and we're saying all the sides should be equal. Okay, fine. Then now the other part is saying labeling the length of the sides. So we must also know the length of the sides. So we said the total length is 30 centimeters. Okay, how many sides do we have? We have got 6. So we can say 6x is equal to 30 centimeters. What is the value of 1x? So you find out the value of 1x, we can divide every side by a 6. This side, they cancel off each other. Here we get a 5. So our x is going to be equal to a 5 centimeter. So we are done. So if you want to make it nice, you can even label here and you'll be just saying 5 centimeter, 5 centimeter. It's still fine. Okay, let's move on. Okay, so here we've got some temperatures in degrees Celsius. Write these temperatures in order of the coldest to the hottest. So the coldest, we have a very big negative number. Like in this case, the biggest is minus 21. So we can say minus 21 followed by minus 17. So I can minus 18, sorry, minus 18. Then minus 10. Minus 10. Then we have minus 2. And lastly, 17. So basically, when we have a temperature, it's no longer cold. This is now chilly, not cold. Okay, so that's basically how you can arrange them in order. Then they say, work out the temperature that is 5 degrees colder than minus 18. So colder, remember I said colder, it means it has got highest and negative value. So if it's going to be 5, so I can say minus 18 degrees minus 5 degrees again. Okay, let me see degrees Celsius. So this is going to give me minus 23 degrees Celsius. Okay, so our value is minus 23 here. Okay, that's the coldest temperature we can get, which is 5 degrees colder. Okay, let's move on. Number 8. A rope is cut into 3 pieces with lengths in the ratio that the length of the shortest piece of rope is 180. So the shortest, you can check on our ratios here, which one is the smallest number. So the smallest number here is 3. So that's the one that is related or corresponding to 180 degrees, 180 centimeters. I don't know what, I'm used to the previous question, that's why I'm saying degrees. Okay, fine. So they are saying find the length in centimeter of the longest piece of the rope. The longest piece is going to be this one, 5 here. That's the longest. But how do we calculate it? The easiest way is to find the total length of the whole rope. Then we find for 5. Okay, so let's find the total ratio, our total ratio. Okay, so our total ratio is equal to, we are saying 3 plus a 5 plus a 4. Okay, we get, this gives us what? 9, 12. So our total ratio is 12. So the 180 is 3 over 12. So we can say 3 over 12 is equal to our 180 centimeters here. Okay, so what I've written here is for 3 over 12, it's 180. What about when it's 12 over 12? So we can say 12 over 3 times 180, so that we get what is the total length of this rope. So I can say 3 into 180, 3 here can go into 18, 6, and 0. So I have 60 times 12. Okay. 60 times 12, this gives me 720 centimeters. So this is the total length of the rope. Okay, this is our total length of rope. Okay, we want the length of 5 over 12. So I can say 5 over 12 times my 720. Okay, so now I can say 720 divided by a 12. Okay, so if I do that, this I can say 6 here, 2, 6 here, 1, remainder 1, 6 into 12, that's 20. So this is going to give me 60. 60 times 5. So I have 60 times a 5. 60 times 5, I think this should give us a 300. Okay, so it means the longest length is going to be 300 centimeter. Okay, so basically we have found the length of the 5 and the 3. If we wanted to find for 4, you can just say that would be like, you can say, I think I've answered all the questions actually. Oh my God. Let's see the next question. Find the total length of the rope. You said this is 720 centimeter, but they want the answer in meters. So we are going to divide this by 100. Okay, remember 1 meter is equal to 100 centimeters. Okay, so if we have 720, it means we have got, we are dividing here, we're going to get ourselves 7.2 meters. Okay, fine. So I was saying if we want to find the ratio for 4, you can just simply say 4 over 12. 4 over 12 is going to give you 720 minus 180 minus the 300. That's the easiest way you can do, or else you're going to multiply. Another way is 4 over 12 multiplied by our 720. You will still get the same answer. Okay, let's move on. The diagram shows triangles A and B. Okay, fine. Then they are saying describe the single transformation that is going to map A onto B. So basically here, when I just look at it, I can see if I'm to rotate like this, if I'm to rotate A like this, I'm going to move it like this. It's moving like this. That's the way I'm saying I'm rotating like this. I can have a center point, this one, like this. I can have my center point here. I can have my center point like here. Okay, this is my center point here. Okay, I don't know what's happening. Okay. So this is my center point. Okay, fine, like this. So this is my center point. And I can tell that this is making like a 90 degrees because I've joined 2 points. I can as well join these longer points here and this other one here. So I'm just connecting. You see, it's still 90 degrees. So if we are to describe it, we can say this is going to be a rotation. So number 1 point, we are saying it's rotation. Okay. What is the angle of rotation? 90 degrees. What is the direction of rotation? It's clockwise. Okay. It's clockwise direction. Then another point we need to include is that the center of rotation. So our center of rotation, we said center is our center is 0, 0 or origin. So we can say 0, 0 or the origin. Okay. It's still okay. Fine. So these 3 points, so you have to mention that it's rotation, the angle of rotation and the direction, then also the center of rotation. Those 3 points will give you, that's why actually there are 3 point marks there. Let's move on. Work out 1 over that times that, give your answer as a mixed number. Mixed number, okay, like that. Okay, so let's see, we are saying 1 and 1 over 3 times 8 over 9. So here we can multiply and here we are adding. So 3 times 3, we get a 3 plus 1, we get 4. So this is going to be 4 over a 3 times our 8 over a 9. Okay, so I don't think we can simplify this one. So we are going to get ourselves 4 times 8. 4 times 8, that will give us 32. So this is going to give us a 32 over 3 times 9, that's a 27. Okay, so when it's like this, it's an improper fraction. This is an improper fraction. Okay, but we want us to have a mixed. So we are going to say 27 into 32, it is going to give us a 1. So we have a 1 here. And then what is the remainder? 32 minus 27, that's a 5. So we get 1 and 5 over 27. Now it's a mixed number. Let's move on. Okay, Kat has a bunch of grapes. She ate 1 over 4 of the grapes in the morning, 2 over 3 of the grapes in the afternoon. Work out the fractions of the grapes that she has not eaten. So basically we can say the total bunch of the grapes is X. So we can say this is an X. So if she ate 1 over 3, the remaining is going to be 1 over 4. The remaining is going to be 1 over 4 of X. X, remember, is the initial grape bunch. Then she ate again later on in the afternoon 2 over 3 of the grapes that have been left in the morning. So this is going to be 3 over 4x minus a 2 over 3x. So basically we are going to simplify this fraction. Okay, so let's simplify it. I've got 3 over 4 minus 2 over 3. Let's simplify this. So the lowest common multiple is a 12 here. It's a 12, so I can have a 12 here. Okay, 4 into 12, that's a 3, so I have 3 times 3. Minus 3 into 12, that's a 4, so I have a 4 times a 2. Okay, so what do we get there? We get 3 times 3, that's a 9, minus an 8 over a 12. So the fraction of the grapes that have not been eaten is going to be 9 minus 8, that's a 1. So we are going to get ourselves a 1 over a 12. That's the fraction that has not been eaten. Okay, let's move on. Now, we are saying solve the inequality. So basically, when you are solving an inequality, you can take that this sign is like an equal sign. Okay, so let's do that. So I can say x minus a 5 is equal to 3x plus 7. Okay, so let's simplify it. I can take my x this side. So this x is coming this side. Then this 7 goes there, it becomes a minus. So I now have minus 5 minus 7 is equal to 3x minus an x. Okay, like that. So here I get minus a 12. Okay, minus 12 is equal to 2x. Okay, this is giving me 2x. So to get my x value, I'm going to divide every side by 2. So here by 2. So I get minus 6. So x minus 6, I can say minus 6. Here, I'm going to say minus 6 is equal to, minus 6 is equals to my x. Okay, taking my sign now, it was saying, it was like this. So I can say my x is going to be equal to, is less than actually minus 6. Okay, that's basically what I can say. My x is less than minus 6. Okay, because if I take here, I'm taking it from this point. If I take x is equal, this is the normal way we write it, is equals to a minus 6 I have interchanged, so I also interchange this sign here as well. Okay. But if I leave it the way it is, I can have it like, I can have it like -6 is greater than x. Okay. So this is one and the same thing, but it's proper to write x first, like what I've written there. Okay, let's move on, number 12. Okay, Ali keeps a record of the computer games he plays. Out of 6 games, he wins 4. Out of 20 games, he wins 13. So basically on this one, he lost 2. On this one, he lost 7. Okay, fine. Use these results to find the best estimate for the probability that Ali will not win the next computer game. So basically on this note, it's best, because they say estimate, best estimate. We can use larger numbers, like where he played 20 more games than using 6 games, which are fewer. The probability that they are going to give us is not a best estimate. So the probability is going to be basically 7 over our total number of games, which is our 20. So that's the probability there. If you want, you can have it as a decimal. It's fine. Then we have the next one. A spinner is spun n times. The spinner lands on red 14 times. The relative frequency of the spinner landing on red is 0.2. Okay, so fine. So remember, we said for us to know the probability, we can say number of times over number of getting red over the number of times that we have spun the spinner is going to give us, in this case, 0.2. So they want to find what is the value of n. So we can write 14 is equal to 0.2n. So I can divide every side by 0.2. Okay, by 0.2. So this side, they cancel off each other, and we can divide and get our n as equal to a 70. Okay, so that's our n value there. It's a 70. Fine, let's move on. The bearing of mean field from Langton is 156. Okay, fine. So basically, the best way is to draw and visualize how you can get from, they're saying from, okay, fine. So I can say this is my L, my Langton. My Langton, I'm going to say it's L, and then mean field is my M. So the bearing here, I can have my compass. This is my north, okay, south and east and west. Okay, fine. So this is 90 degrees. So basically, when I say the bearing of mean field from Langton is 150, so this is 90. So I want 156. It's less than 180 because the whole line straight here is 180. So I'm gonna estimate and say it's going to be somewhere here. Okay. I don't mind my line. It's not really nice, but that's basically where it is going. Somewhere there. So this is somewhere where we have our M. Okay. So now they say calculate the bearing of Langton from length. So we are now starting from here. So you can have your true north here. Okay, fine. So what happens is this. The bearing we are wanting is this whole bearing that I've indicated. So to get that, we can say this set angle here, this is an alternating angle. So I can say 180 degrees minus 156 degrees. What do we get? 180 minus 156. Okay, I'm getting 24. This is getting me 24 here, 24 degrees. Okay, so it means this point here is 24 degrees. When I have that point as 24, this is also 24 here. Okay, so angles on a point, this point on mean field is 360. To go right round is 360. So to get the bearing, it's going to be 360 degrees minus 24 degrees. Okay. So if you subtract this, you get yourself a 336 degrees. That's the bearing. Okay. Let's move on. Sorry, I've written there. On the map, the distance between Langton Field is 4.5 centimeter, yet the actual length is 9 kilometer. Okay, so they want us to write the ratio. So when we are writing our ratio, we are going to have all the dimensions in centimeters in this case. Okay, so we have got 4.5 centimeter as to 9 kilometer. Let's change this kilometer to centimeter. Okay, let's change it. So this is going to give us 4.5, okay, as to 9. So centimeter to meter, we multiply by 100. Then meter to kilometer, we multiply by 1,000. So we have so many zeros now. Okay, so this is going to give us 44.5 as to, we have 9 and 5 zeros. 1, 2, 3, 4, 5. Okay, so we are going to divide all the sides by 4.5. 4.5. Okay, so we divide also 900,000 by 4.5. Okay, so this side we are going to get a 1 as to, okay, this is going to give us a 1 as to 200,000. Okay, 4.5 here is going to go in here 200 times. So I get myself here 200,000. Okay, now let's move on. Fine. Now we are on number 14. Number 14 is saying, expand and simplify. So we are going to remove brackets. So let's remove the brackets first. Okay, so 5 times 5, 3x there, we get 15x minus 5 times 2, we get minus 10 there. Then here, this part here, we've got minus 3 times 2x, that is going to give us minus 6x. Then minus 3 times minus 3, we get a plus 9. Okay, so when we get a plus 9 there, let me see. Okay, fine. When we get a plus 9 there, we are going to say 15x, we group terms 15x minus 6x. Then this one and this one, we have minus 10 plus a 9. 15x minus 6x, that's a 9x there, okay? Then minus 10 plus 9, that's a minus 1. So this is our final answer, 9x minus 1. Let's move on. We are removing brackets. For this one, the easiest way is to do this. You take this first term, multiply it with the bracket, then you take this term again, multiply with the bracket. So let's do that. That's basically what I'm going to do. Okay, so I'll have, this is equal to 2x multiplying x minus 7, then plus 3 multiplying x minus 7, like that. So I'm going to get 2x by x, that's 2x squared. 2x by minus 7, that's minus 14x. Then plus 3 times x, that's a plus 3x there. Then 3 by minus 7, that's a minus 20, 7, 14, 21. Okay, so we get ourselves 2x squared, then minus 14, this part here, plus this one, we get minus 11x, then minus 21. Okay, so this is our final answer, 2x squared minus 11x minus 21. Okay, let's move on. Number 15. These are the first 4 terms of a sequence. We have 1, 7, 13, and 19. So we can check what is the difference on these terms. So 1 to 7, that's 6. 7 to 13, that's a 6 again. Then 13 to 19, that's a 6. So this sequence is an arithmetic sequence. This is an arithmetic sequence. You find out they've got a common difference, which is a 6. So we can use the common difference 6 to generate the expression in terms of n of the nth term that we need for this sequence. So we can use, so this is our term number 1, term number 2, term number 3, and term number 4. So it's easy. I'm going to start with term number 2. So for us, using the common difference 6, to get term number 2, we are saying, to get our term number 2, we are saying 6 times 1 plus 1, we get plus 1 here, plus the 1. Let me add plus 1. Plus 1, we get 7. Term number 3, we are saying, to get term number 3, we are saying 6 times 2 plus 1, we get 13. Okay. Then term number 4, we are saying, to get to it, we are saying 6 times 3 plus a 1, we get 19. So you find out I can rewrite this in using the term number, because here I was saying this is a general term. I was just checking how we are getting this term 2, 3, and 4. I can generate using their term positions and say, okay, for T1, I can say 6 by 2, that's our position number 2, minus 1, then plus a 1. So this is going to give me the same scenario here where I will have 6 times 1 plus 1. For the term number 3 is the same. I can say 6, 3, position number 3 minus 1, or term number 3 minus 1 plus a 1. Then the last one, 6 by 4 minus 1 plus a 1. Okay, so you can find out these are positions or terms. So these are our nth positions or terms. So I can replace these and say, for my nth term, I can say I have nth term is going to be equal to, so my Tn, which is my nth term, is going to be equal to 6n minus 1, because this is my nth term here, then plus a 1. So let's solve this and see what we get. So I'm now solving for this. I will get Tn is equal to 6n minus 6, then plus a 1. This is going to give me Tn, the term is equal to 6n minus a 5. So this is how we get the general term and say it's going to be 6n minus a 5. We have this sector. So basically when we have a sector, we have a center, this is the center O. So this is the radius. So we can say the area of the sector is 30 pi. Okay, then find x. Okay, we want to find the angle. Area of a sector, theta over 360 degrees times pi times pi times r squared. Okay, times r squared in this case. Okay, so I can say my area, this is going to be 30 pi, because this is the formula of an area. 30 pi is equal to this x angle, this theta here is x over 360 degrees times pi times my r is 20 squared, like that. Okay, so let's simplify it. So I have 30x over 360 times pi. So I can do away with the pi's here, because if I divide this, both sides, the pi's, they go away. Okay, fine. 20 times 20, I think we get 400. 20 times 20, because 4 times 4, that's 2 times 2, that's a 4. We add 2 zeros, so this is 400. Then I cancel these zeros here. I can have 2 into there, 2 here 1, remainder 1, 18, 2 here 20. Okay, so to get our x, we are going to say 30 times 16 divided by a 20 is giving us an x. So this 0 and this 0 cancel, 2 here 8. So I have 8 times 3. Okay, this was not 16, this was 18. That's why this was 18 here. So it was going to go here 9 times. So we have 3 times a 9 is given as x. So our x is 27. Okay, 27 centimeter. Don't forget the units. Okay, fine. Let's move on. Number 17, the mass of the planet is that. Then the mass of Venus is that. So they want the difference. So I can say 5.7 times 10 to the power of 26. Okay, minus, because that's the difference, 4.9 times 10 to the power of 24. Okay, let's subtract these two. So the easiest way to subtract is going to be like here, 5.7 times 10 to the power of 2, okay, minus 4.9. Then the whole answer, I'm multiplying by times 10 to the power of 24. What I've done is I've taken the smallest power. Then for here, I've subtracted it there. That's why I have a 2 here. Okay. So this is going to give me like 5.7 is the same as 57012. Yes. Minus 4.9. Then the answer we multiply by times 10 to the power of 24. So we can subtract 570 minus 4.9. Okay, so here I can put an imaginary 0, 10, 5 here, 1, 1. So I have 1, that's a 5, that's a 6, that's a 5. So we are getting 565.1 times 10 to the power of 24. But here it's not in the form A times 10 to the power of n, where our A is 1 to 9 only. Okay, so I'm going to move my decimal 1, 2. So I will add plus 2 here. So our answer is 5.651 times 10 to the power of 26. Y is equals to that. Rearrange the formula to make x the subject of formula. Fine. So the first thing we do away with this square root sign. So to get rid of that, we square every side. So we square this side, we square our y as well. The idea is that when you have a square root, it's like to the power of half. Then when you square, you are multiplying by 2 over 1, such that these, they cancel off each other. That's basically what we are doing. So we now get y squared is equal to x plus 2 over 3. So we want to make x the subject of formula. We are going to multiply every side by a 3, So here I'll have, they cancel off each other. Then here I have 3y squared is equal to x plus a 2. Okay. So we can get our x by subtracting 2 there. So it means our x is going to be equal to 3y squared minus a 2. Okay, so that's our x there, 3y squared minus a 2. Fine, let's move on. Here, so these are tangents. This line that touches the circumference of a circle is a tangent. Okay, so these are our tangents. Then this is a radius. This line here is a radius. So the angle that is going to be formed there is 90 degrees. Here also is 90 degrees. Okay, so these are 90 degrees. Okay, then from this, we can like use Pythagoras theorem and say, okay, fine, this OT line here, I can get it using this side. So I can say OT squared is equal to I can say BT. Let's say BT squared plus OB squared. Okay, then I can get also OT squared by AT squared plus OA squared. Okay, so you can see that if I do this, this is equal to each other. I can find it the same way. Okay, so the side BT is equal to AT. That's basically what I'm relating here. BT is equal to AT. And my side OA is equal to my OB, because these are both our radiuses. Okay. Okay, fine. Let's answer the question. They're saying, show that the triangles OBT, this one, and OAT are congruent. I think we have shown that they are congruent basically by also having an angle on the same point here where we were saying this B and this T, that's where we are getting our 90 degrees. Okay, so you can as well just say that. Okay, or else if you want, you can say OT. So you can also say OT is common. OT is common for both triangles. Then we can also say AT is equals to BT. They are equal. They are equal. Like what we have just they are equal, like what we have just derived here. Okay, we say they are equal there. Okay, if you want, you can even use the radius and say the radius are equal. Then that's how you can just give your statement that they are congruent. Okay, fine. Let's find the inverse of a f of x there. Okay, so to find the inverse, we can say let f of x be equal to y. Okay, so when we let f of x be equal to y, we are just going to say y is equal to 10 plus 7x. Now the idea, we want to make x the subject of formula. So we can say y minus 10, I'm taking 10 this side. Okay, so y minus 10 is equals to 7x. Dividing every side by 7, I get my x is equals to y minus 10 over 7. So this is the f of x, inverse of f of x. So we can say f of x is going to be equal to y minus, instead of writing y now, we put an x, sorry. You now put an x. So here you replace this by x. Okay, so we now have x here minus 10 over 7. That's our inverse. We are done. Let's move on, number 21. The diagram shows two rectangles. Okay, rectangle ABC is mathematically similar to PQR, that is inside. AB is 12 and BC is 9. Okay, so this is 12, 9. Okay, then PQ is 8, so this is also 8 there. 8s to 12. Okay, then what is 9s to what? It's gonna be less, huh? So I can say, if it's going to be less, I can say 9 over 12 times 8. Okay, 4 here, that's 3. 4 here, 2. 3 here, 1. 3 here, 3. 3 times 2, that's a 6. So this is a 6. This is a 6. Okay, fine. Then let's see the shaded area. Shaded area, we're going to say the bigger area of the rectangle minus the smaller that is inside, because this is not shaded. This area is not shaded. So we're going to say the shaded area is going to be equal to Big rectangle, area A, B, C, D, minus area P, Q, R, S. Okay, that's how we are going to get the shaded region. So this is going to be a 12 by a 9 minus a 8 by a 6. Get 108 here minus 8 by a 6. That's a 48. If we subtract these two, we are going to get ourselves 60 centimeter square. That's how we get the shaded area. Okay, let's move on. Factorize. Okay, let's factorize this one. 6 into 21, it can go there. Okay, fine. So I'm going to rearrange this first. I'm going to rearrange this. Okay, so I can have 7, let me see, 7y. I can have 7y minus 21, then plus 2xy minus 6x. I think this will make sense. So I can take away a 7 for this group here. 7, then remain with y minus 3. Okay. Then for this other part here, I can take away plus 2x. Then I'll remain with a y minus 3. Fine. Then I can write my final answer as 7 plus 2x. Then y minus 3. Okay, perfect. Then let's do the next one. 3a squared. Okay, so first of all, let's take out 3 there. So if we take out, because 3 is common, so I can have 3. Then we remain with a squared minus 3 into 12, that's a 4. 4b squared. Okay, so basically this is a perfect square. Okay, this is a perfect square. Okay, so when we have a perfect square, we can just simplify it and say a minus 2b and a plus 2b. We are done. That's the final answer, this one. Okay. Number 23, the attendance at a cricket match is 36,000. Correct to the nearest 1,000. So this number is corrected to the nearest 1,000. So the first question is saying, write down the minimum number of people at the cricket match. So the minimum number that we can have, that we can round off to 36,000 is 35,500 here like this. This number, 500, can be rounded off to get 36,000 then. Okay, so that's our answer. Let's move on to the next question. The number of males attending the match is 21,000. Correct to the nearest 500 there. So this number, okay, let's go to the next question. What it is saying, find the maximum number of females that could be attending. So let's find a number that we can have that can be rounded off to 21,000 because this is corrected to the nearest. So you find out the number that we can have is 20,750. You can round off this whole number to the nearest 500 and you get 21,000 there. Then they say find the maximum number of females that could be attending the cricket. So we should also find from our 36,000, we can also find what is the maximum number that we can round off to 36,000. So you find out the maximum number that we can have is 36. We can have 36,499. This number is below a 500, like on this case here. Okay, so if it is like this, it can be rounded off to 36,000. So this is our maximum number of females that are attending the cricket match. So we have, this is the number of all the people, which is 36,499 minus the maximum number that we can have for our male is this number here. Okay. So we subtract the 2, 2750. If we subtract the 2, we are going to get 15,749. This is our answer there. Okay. Okay. 10 batteries are tested to see how long they last. The table shows the result below. So, okay. Okay, basically here, when you see this, it's very important, frequency density. So we can calculate frequency density here. Let's calculate the frequency density. I say frequency density, FD is equals to our frequency divided by our number there, by our class width. Okay, so for this one here, let's find the frequency densities there. Okay, so this class width is 5. This one is 21 minus 15, that's it's a 7 here. 30 minus 21, that's a 9. 30 minus, that's a 20. Okay, fine. So 10 divided by 5, for this one, 10 over a 5, we get a 2. Okay, so this is our frequency density at 2. Okay, 21 minus 15, it's a 6. Where did I get 7 from? Okay, so 24 divided by 6, then 36 divided by a 9. 36 divided by 9, that's a 4. Here we also have a 4. And then lastly, 30 divided by 20, that's a 1.5. So we have a 1.5 here. Okay, fine. Let's go and draw the graph. At the center, 2, 4, 5. This is our 15. This is our 25 here at the center. 2, 4, 5. This is our 25. This is our 35. Our 45 here. Okay, fine. So 10 to 15, that's a 2. That's a 2. So we come here and we draw like this. So it's down like this. Then 15 to 20, they've already drawn us. It's 4. You can see here it's reaching 4 here. Okay. Then let's draw the next one. It's a 4, which is from 21 to 30. 21 to 30. 21. So we are ending here at 30. Then we go down a straight line. Mine is not really a straight line. So here, straight there. Then it goes down a straight line. Let me try to have a straight line. Straight line here. Okay. Like that. Then from 30 to 50, that's 1.5. 1.5 is here. So if I move here, somewhere here, 30 to 50. So this is basically our frequency density graph. Okay, we are done. Number 25, we have got a x to the power of b, or in brackets to the power of 3 and this. So we want to find the value of a and b. So the easiest way we can do is to rewrite this number 27x to the power of 4 in the format of ax b to the power of 3, like that. So we can have a x to the power of b to the power of 3 is equal to 27 is 3 to the power of 3, so we can have 3 to the power of 3, and then we have x to the power of 4 like this. So when we have this, I can take out 3. Okay, so I'm going to take out 3 here. So I'll have 3, then I have x to the power of 4 over 3, so that I can take out a 3. So if I take out a 3 like this, you find out, I'm just considering x here. If I say x to the power of 4 over 3 times 3 over 1, I'll get x to the power of 4. So when we rewrite it like this, it's now similar. So when it's similar, it means our a is equal to a 3. Our b is equal to a 4 over a 3. Okay, let's move on. Number 26. A is the point that, and B is the point that. Okay, fine. Find the midpoint of AB. Okay, this is our X value, our Y value, our X value, our Y value. Okay, so to get your midpoint, we are going to say you add the X values and you divide by 2. The Y values, you divide by 2. So I can say my midpoint is equal to, for X values, that's minus 2 plus a 4. Plus a 4 divided by a 2. S2, so this is how we write a point. The other one is 3 plus a 7 over a 2. Okay, so let's divide this. I'm going to get minus 2 plus 4, that's a 2 over 2, S2. 3 plus, that's a 10 over 2. So I'm getting 2 by 2, that's a 1, S2, a 5. So this is my midpoint there. Then the next question is saying, line L is the locus of points. So locus of points is line that will be like saying, if I have AB, it's going to pass, so this will be my A, and this will be my B. It's going to pass through the center, making a 90 degrees here, something like that, okay? That's locus of point, equidistance from point A and point B. So they're saying find the equation of L. So we want to find this L here. Basically, we have to find the gradient of AB. So let's start finding the gradient M of AB, So the gradient is going to be equal to, I can take 7 minus 3 over 4 minus 2. Okay, like that. That's my gradient. So this is going to give me, because I'm just doing change in Y over change in X. Okay. So this is going to give me 7 minus 3, that's a 4. Okay. Over a 6. So this is 2 over 3. That's my gradient for AB. Then the gradient for L now, it's at 90 degrees. Gradient of L, this gradient times minus 1, 2 over 3 times M is equals to minus 1. This is minus 1. So we get the inverse, which is minus now. So our M is equals to a minus 3 over 2. Okay, that's the gradient of M. Now to get its equation now. Its equation we can say, because we know Y is equals to mx plus a c. So the gradient, we now have it. So we can say Y minus its point, we say the points are 5 and 1. So I can say Y minus a 5, because this is my Y, this is my X. Okay, so I can say Y minus 5 is equals to my gradient minus 3 over 2x minus a 1 here, multiplying by x minus a 1 here. So basically the idea now is for us to simplify this whole thing. So if I am to simplify, I get 2y minus 10 here. 2y minus 10 is equals to minus 3x plus 3 here. Okay, let's simplify. So we get 2y plus 2y plus 3x then is equals to 13. That's a nice equation. We can leave it like this. If you want to write it in the form of y is equals to, you can still do that. But this is okay as it is, okay? Number 27. We are given a parallelogram. So if it's a parallelogram and this side, it's going to be parallel to this side. Here, it's going to be parallel to this side. So here I can also have 2a, and AB is also going to be parallel to OC, so I'll also have a 3C there. That's very important. Let's move on. So if you are writing, you can write a dash on top there to show that it is a vector. Then we are also giving that M is a midpoint on BC. Okay, fine. Then T is the midpoint on OB. Fine. Then we are given that OT S to TB is 3:1. So this is 2 and this is 1. So our total ratio there, our total ratio is equal to a 3. Okay, fine. Let's find, the first question is saying find OB in terms of A and C. Where is our OB? OB is this one. Okay, so we want to find a route that we can follow from O to B. To find out the route that we can follow is saying, we can say OB, vector OB is equal to, we can go via OA plus AB. Okay, so that's the route we can go via OA. So this is going to give us a 2A plus a 3C. So that's our OB. Let's write our answer. 2A plus a 3C. Okay, fine. The next question is saying express as simply as possible in terms of A and C, AM. Let's see, where is our AM? Okay, so we are moving from A, there to our midpoint M there. So this is the direction. So we can check which route can we follow. Okay, so you find out the easiest route that I can follow is AB and BM. Okay, so when I'm going via BM, remember I will be going down, opposing the original direction of CB, which is 2A. So I'll have a negative, and also this is our midpoint. So when it's 2A here, it means this part here is A and this part here is A. Okay, so let's write our A. Our AM is going to be equal to AB plus our BM. Okay, like that. What is our AB? Our AB is 3C. What is our BM? We said it's opposing, going down, so it's a negative A. So this is our vector AM. It's 3C minus an A, like that. Let's go to the next one. The next one is saying, find AT. Find AT. We want to find AT. Okay, so we want to find A to T like this. Okay. So this is what we are looking for. So you find out our AT, we can find it following the route AO, this one, AO plus OT. Okay, so let's find it. So I can say my AT is equal to AO plus OT. We don't have OT, but we have OB, and we can use the ratios and say to get OT, it's going to be 2/3 of OB, vector OB. So that's what we are going to do. So this is going to give us AO is, we are opposing, it's going up, A is going up, then AO is going to go down. So it's going to be a minus 2A here, plus 2/3 of OB, we got OB here, is 2A plus a 3C. So let's simplify, because they said simplify as simple as possible. So if we simplify this, we are going to get, this is going to be equal to minus 2A, then plus, this will give me a 4A/3, then plus a 2C, okay? Because if I say 2/3 times 3, I get a 2. 2/3 times a 2A, I get a 4. So I'll try also to write minus 2A in the form of 3. with a denominator of 3. So this is going to be minus 6 over 3a plus 4a over 3, then plus our 2c. So they have now a common denominator. I can easily subtract them or add them together. So this is going to give me minus 6 plus 4. That will give me a minus 2 over 3a. Okay, then plus our 2c. So our final answer is 2c. I can rewrite using a positive first and then a minus 2 over 3a. So this is our vector AT. Let's write it down. AT is equal to 2c minus 2 over 3a, like that. Now they are saying, show that ATM is a straight line. Okay, fine. ATM, show that ATM is a straight line. Okay, so to show that ATM is a straight line, we are going to say ratio of AM is to AT. We can use that because we have calculated AM, we have calculated AT. So I'm going to use these two vectors, this one and this one. Okay, so when we do their ratio, if they have same vectors and the other one have a scalar, then it means it's a straight line. So let's use that information. So our A, we are saying AM is to AT. Our AT is 2c minus 2 over 3a. Then our AM is 3c minus an a, like that. Okay, so let's see. I can write 3c minus a s2. So this vector s2. Here I can take out or multiply everything. I can multiply everything here by 3 over 2. If I multiply everything by 3 over 2, I'm going to get, for C there, it's going to give me 2 by this, they cancel, so I'll have 3c, then minus this one, they all cancel off each other, and I get a 1a, so I'll have an a. So what it means is this, I factored out 3 over 2 here. And this part of the vector is now similar to this part of the vector. So it means when they are similar like this, it means it's a straight line. And it has got a scalar of a 3 over 2 there. So we can deduce and show that it's a straight line. Okay, so that's our final answer there. It's a straight line because of that. Okay, guys, this is our last question. Thank you for going through the questions with me. Please remember to subscribe on my YouTube channel, Mobilemaths, like and follow. Bye-bye.